In the last part of the problem, we figured out that the function of the height of the Ferris wheel, of the people of the Ferris wheel at any time is a function of t. H of t is equal to 9 minus 8 cosine of 18t, where t is in seconds. Now, the second part of this problem, they want us to graph h as a function of t between between 0 is less than or equal to t is less than or equal to 30. So let me draw axes. So let's say that that's my h-axis. And let's say that this is my t-axis. This is h, and this is t. And so this is t equals 0, and this is t is equal to 30 seconds. 30 seconds. I get confused when I see this 18 here or whatever. So what I'm going to do first of all is I'm going to graph a different function, slightly different function, then I'll translate it to this function. I'm going to graph h of theta is equal to 9 minus 9 minus 8 cosine of theta. And I think you'll see where I'm going with this when I'm all done. So let's try to graph h of theta is equal to 9 minus 8 cosine of theta. So when t is equal to 30 seconds, what is theta equal to? So 30 times 18, that's 540. So this is 540 degrees. Same thing. I'll write the thetas in red above the t-axis. This is 540 degrees. So that's like 2 times around the circle. So that's 540 degrees. Then this is going to be roughly 270 degrees. 270 degrees. And so 90 degrees would be about a third of this. So that would be 90 degrees. That'd be 180. So that'd be 90 degrees. That'd be 180 degrees. This would be 360 degrees. 360 degrees. And then this would be 360 plus 9. This would be 450 degrees. And if you wanted to figure out the corresponding time, you just take this degree and divide by 18. So it's 90 divided by 18 is what? It's 5, right? 5 times, yeah. So this is, so if I were to write here, this is at 5 seconds. 5 seconds. This is at 10 seconds. This is 15 seconds. This is 20 seconds. This is this is 25 seconds, and this is 30 seconds, right? And actually, a simple thing we could do is let's just do it. Let's just figure out what the value of the function is at these points, because these are pretty easy degrees to figure out what the cosine value is. So let's figure out. Let me draw a table. Tables are always good, and I'll do it in yellow. So I'll draw t, theta, and h. This might be kind of unconventional way of doing things, but I have a simple mind, so this is actually how I like to do it. So I like to think of theta as 0, 90, 180, 270, 360, 450, and 540. It's 450. And t, the corresponding time of those is 0, 5, 10, 15, 20, 25, 30. And you could, it's not rocket science here. When t equals 15 seconds, 15 times 18, we're trying to find the cosine of 270 degrees, right? 15 times 18 is 270 degrees. I'm just doing this because I don't have a calculator, and this will help me pick good points. So when t is equal 0, what is height? Well, or t is equal 0, theta is equal to 0. So cosine of theta is, cosine of 0 is 1. So 9 minus 8, it's 1. Let me do h in a different color. So this is 1. Cosine of 90 degrees, cosine of 90 degrees is 0. So 9 minus 0 is 9. Cosine of 180 degrees, we're going all the way around the unit circle. So cosine of 180 degrees is minus 1. So minus 1 times minus 8 is plus 8. So 9 plus 8, that's 15. Cosine of 270 degrees, we're pointing straight down. So the x-coordinate is going to be 0. So once again, we're at 9 again. All right, 9 minus 0. 360 degrees. Cosine of 360 degrees is the same thing as cosine of 0, right? So once again, I mean, we've gone around the circle once, right? So it's going to be the same as 0, so it's going to be 1. And 450 is going to be the same thing as 90, so it's going to be 9. And then 15 degrees. So let's plot these points. Actually, let me just draw 15 up here. So if this is, so what are the points that keep showing up? So if this is 1, that's 1, that's 1, and then let's see, then we have 9. 1, let me just 2, 3, 4, 5, 6, 7, 8, 9. 9, 10, 11, 12, 13, 14, 15. 15. All right, fair enough. Okay, so if let me draw some guidelines just to help us. This is a little bit. So I'll draw. Actually, let me do them kind of hard to see, just because I don't want to draw too much attention to the guidelines. So I could do one guideline like there. Then I'll do a bottom guideline right there. Bottom guideline right there. And then the 9 keeps showing up. 9. Oh, you know what? I can't add. What's 9? What's 9 plus 8? It's not 15. It's 17. Sorry, I can't. I don't know why I'm. Right? When clearly I need to practice my addition. So this is 9 plus 8. This is 17. And I realized that just because I was like, well, 9 should be in the middle. So this is actually 17. Ignore my little marks here. That's 17. This is 1. And just ignore the marks. 9 would be right in the middle between 1 and 17. So let me draw kind of that median point right there. So this is at 9. Sorry, I can't add properly. And then let's draw the graph. Or at least plot the points on the graph. So at 0, at t equals 0, we're at h equals 1. So that's this point. That's right here. When t equals 5, h is equal to 9. It's right here. When t is equal to 10, h is equal to 17. H is 17. When t is equal to 15, h is 9 again, so it's right here. At 20, we're back at 1. I think you see the pattern. At 25, we're back at 9. And then at 30, we're back at 17, not 15, because now I've corrected my mistake. And this is going to be a sine graph, so it's going to look something like this. It's going to look, let me do it in a vibrant color so I can kind of overwrite everything. It's going to look like something like this. It's going to go whoops, and then up, and then down here. Oh, whoops, my thing disappeared. So it's going to go up like this, curve up, come back down, and then curve up, and then come back down like that. So that's our graph. So if I think in the problem they tell us to approximate. Actually, let me open up my cousin's problem. My other account has timed out on me while I recorded this. They wanted to approximate when t equals 4 what the height is. So when t equals 4, the height is like, I don't know, it's like right around there, right? So the height is a little bit less than 9, and so it's, I don't know, 7 or 8 meters in the air. And when time is equal to 10, well, time equals 10, we figure out exactly. We know that they're 17 meters in the air. So I know this was kind of a little messy, and graphing trig functions tend to be, but hopefully you found this vaguely useful. Have fun.